Hello, physics. Heat conduction. The problem is that the temperature within the Earth crust increases about 1 Celsius for each 30-meter depth, and thermal conductivity of the crust is 0.80 watt per Celsius into meter. Number one, determine the heat transfer from interior to the surface of the Earth in 1 day. Number two, compare this heat to the energy incident on the earth from the sun. So, first of all, we have to consider earth. This is earth's center. And suppose this is a crust. So, this is a crust. This radius R E, and this value is equal to 6.38 10 power 6 meter, and there's a heat here, and the heat is going on the crust, and the crust is this is a one degree, one dimension. So the length of this one is 30 meter, and temperature difference delta T is equal to 1 degree C. So we will see we use the heat conduction from interior to the surface. To crust, and the rate of heat flow is given by Q over T, which is equal to K conductivity area into temperature difference T1 minus T2 over L. Area is equal to pi r e square. Conductivity is given 0.8 watt Celsius in meter, and into the area is pi 4 pi r square, 4 pi r e square, and the temperature difference is 1 degree C, and the length is 30 meter, and RE 6.38 into 10 power 6 meter. If we substitute these values, then we got 1.17 into 10 power 18 joule, or we can say, oh, this one into Q into into time t. So if you multiply this one time, so 0.8 4 pi 6.38 10 to the power 6 whole square uh, over 30, multiplied by time 1 day. So the 1 day, 1 day 24 into 60 into 60. So this one, and the answer is equal to 1.17 into 10 power 18 joule, or 1.2 into 10 to the power 18 joule. This is Q interior. So we'll call interior INT. So this is interior. Now this is the sun and this is earth. Earth is perpendicular. The area, suppose this area is perpendicular to this one. So the cross section is perpendicular to the to sun. So this is equal to pi r e square, and solar constant, which is the energy supplied by the sun, watt per meter square. So energy incident from the sun per second. So the Q sun is equal to pi r e square into the solar constant 1350 watt meter square per second, multiplied by second into 10 days. 1 day. So this is multiplied, days mean days have to be converted into seconds. So 86400 divided by day. So this day cancel. So this one will be equal to 1.49 into 10 power 22 joule. So Q sun. This is equation 2. This is equation 1. So the ratio. So equation 1 divided by equation 2. So 1.2 into 10 power 18 joule divided by 1.49 into 10 power 22. So this is equal to 7.9 into 10 power minus 5. Or Q sun is equal to 1.3 into 10 power 4 Q interior. So the solar energy heat transfer from the solar is more than the heat transfer from the interior of this. So this is the answer of this question. So the question is how much heat is transferred from interior to the surface. So we will use this formula Q over heat transfer is equal to conductivity area temperature difference into the L, and the Q interior will be all this figure multiplied by time, and time is 1 day. So this one, so this Celsius meter square, this meter square, this, and this will be meter square here, and watts is the joule second, second cancel, this is joule. So this will be, if you multiply all this one, you will get 1.17 10 power 18, which is 1.2 10 power 18 joule. So similarly, how much is the energy coming per second for the sun. So you use a perpendicular section, pi r square multiplied by the energy supplied, watt per meter square multiplied by time, which is day. So this is 1 point nearly 5 into 10 power 22. So this is the answer.